Dear students, welcome to online virtual classroom of Municipal Corporation of Greater Mumbai. I am Sreekumar. This class is for 5th standard scholarship students. Let me begin the class.
Dear students, we are continuing with the scholarship IT intelligence test logical reasoning. We came across verbal methods of logical reasoning. This video will be about non-verbal logical reasoning. That means a figure is given instead of any word or letters. A figure is given in each question. Most of the time geometrical structures like angle, triangle, quadrilateral, etc. Then the student is asked to count the number of segments or number of ones or two or any other structure in that. That is a methodology. So non-verbal logical reasoning sometimes becomes time-taking and comes under a little tough category. So before getting into such questions, I am going to make you familiar with certain aspects of this kind of figures and its reasoning. Certain fundamental things. First, about segment. You know what is a segment. A segment is a piece of a line having its start point and end point. You know what is a segment. What is shown on the screen is a segment. If I name this segment as AB, or if I name this as AB, and if I name this as A, B, C, depending upon number of points mentioned in that, or I can also name it as A, B, C, D as different points on this line segment. Suppose if there is a question related to segments, it can be how many segments is there? Is only one segment. In this case, how many segments are there? We know that A, B is a segment that is from here to here, A, B. Then another segment is AC, that is from start to end. Then there is BC. That means there are three segments. Understood? If I name it simply as 1 here, 2 here, and if I add 1 plus 2, I get 3, and that is the answer. If you consider number of segments here, it is only 1. Here number of segments over here is 3. AB, BC and AC. Come to the next. Here is a line segment where we have more points on that. So more segments are created. So if I use this technique, numbering each one, 1, 2, 3, 4, right? And I simply add these like 1 plus 2 plus 3 plus 4. Understood? That is 4 plus 3, 7 plus 2, 9 plus 1. 10 segments are there. If you take time to name the segments, you will get 10 segments out of it. The longest is AE, we know, that is 1. And each one of these AB, BC, CD, DE are segments, correct? Then from A to C there will be segment from here to here. Then A to D there will be segment till here. Then there can be a segment BD. Understood? If you keep on writing this way, you will get 10 segments. There can be CE. So like that, the concept of number of segments. Understood? So I'm not wasting time on this particular formula. if it is segment and asking the number of segments, after giving certain points on the segment, we will simply number it like this and we simply add it and get the answer. Because on the other hand, if you keep on writing like this, it will take time. And when we have an easy method to find out the number of segments, we will follow that. So follow this method. Let me go ahead. This is about a segment if it is in a straight segment. Sometimes segments are used to create, this is the triangle. And in a triangle, how many segments are there? A triangle is formed by 3 segments. 3 angles are there, you know very well. And 3 segments are creating. If I name this triangle as A, B, C, I can write the segment as AB, BC, CA, which we have in fact named as sides of the triangle. 3 dots, and what we will say 1 plus 2, 3 are there. But if I create a little different one, a 5-sided figure like this, pentagon, and if I connect all the vertex of this pentagon like this and ask to find out how many segments are there. So if I name this particular pentagon as A, B, C, D, E, I can keep on writing the number of names of the sides of this particular pentagon, but it will take time. It will take time surely. So here there were 3 dots or 3 vertexes were there. Correct? Here there are 5 dots. When there was 3 dots, the answer is 3 segment, and if I say 1 plus 2 equal to 3. So after doing experiment with more number of figures and sometimes quadrilateral, 4-sided, 5-sided, 6-sided, it has been concluded that if there are 5 vertex or 5 dots which connect to make the shape of that, and if you connect all those 5 dots the way I have done here, and the number of segments created will be equal to 1 plus 2 plus 3 plus 4 if there are 5 dots. Just like if there are 3 dots, we added 1 plus 2. If there are 5, we will add 1 plus 2 plus 3 plus 4. And the answer is 10. There will be 10 segments in this particular figure. There is no any formula or mathematics behind it. This is a conclusion after experiment and as well as a shortcut for getting the correct answer. And there is a pattern followed which we converted to a usable equation. So if there are 5 dots or 5 vertex, we will simply add 1 plus 2 plus 3 plus 4. So if there is a figure 8-sided or 8 dots are there, what we are supposed to do, if all those dots are interconnected like this, the number of segments in that particular figure will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. जो answer मिलेगा, that will be the answer to that question. How many segments are there? So first time I am not giving you question and answers. Here I am giving you some idea or technique to find out answer for the questions which are going to come. This is about segment. The same way ideas are developed in the case of other geometric. Now this is a ray. How many segments are, this is single ray. How many segments are there on this ray? Not even single, because segment need to have both ends fixed and points must be there. As far as ray is concerned, one end is fixed, or we can say the start, and the other end is having an arrowhead which tells us that it is infinite, can be extended. But if you put points like this, the ray can be divided into segments. But we know that this is this part. If I name this as A, B, C, D, E and F, we can say that EF is a segment, DE is a segment, CD is a segment, CF is a segment, but this part is not a segment because there is a arrowhead. So in such situation, to count or find out the number of segments, we will not number here. We start numbering from here. 1, 2, 3, 4, 5, and we'll simply add 1, 2, 3, 4 plus 5, which is equal to 15 segments are there. That is a method in the case of array. Let us think about what will happen in the case of a line. In the case of a line, we know that here the segment is not possible because of arrowhead. On the other end also there is an arrowhead. So line segments possibility are here 1, 2, 3, 4. So we will simply add 1 plus 2 plus 3 plus 4 to write that the number of segments are 10. If I name this and start writing the number of segments, I may write AB, BC, CD, DE, which is very evident. Then there will be AC, AD, AE is already written, AE, okay. Then starting from B, AB is already written, right? BC is already written, BD is not written, but there is no time to write like this and get the answer. So this kind of technique will help us. BE is written, and take C, BC is written, CD is also written, AC is also written, CE is not written, so I write that. Understood? As far as CE is not written, AC is written. Now take D. In the case of D, DC is written, it is here. DE is written, it is also here. Okay, AD is written, it is here. PD is written, yes, it is written here. So in that case, that almost everything is over. How many are there now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 are there. So, but it takes time. So better apply the formula. These are topics related to some questions which are going to come to logically say that how many segments are on this ray, which is marked as A, B, C, D, E. So you will not keep on counting, you will apply this technique. Okay, let me go ahead. You know about angles and how angles are formed and how angles are bisected. This is a simple single angle, right? If I name this as angle A, I will write this as angle ABC or BAC, the angle BAC. Okay? But if I put a ray over here, the angle will be divided into two more angles. So total how many angles are there? If I name this as D, you may say the first original angle BAC, then an angle newly formed BAD, and another angle DAC, correct? 3 angles, quite sure, everybody know. If we divide the angle further into more parts, more angles will be formed. When simply by dividing it once, you got 1 plus 2, 3 angle. Understood? If you divide it into 3, then you have to write 1 plus 2 plus 3. The answer is 6. That means if you have one more arrow which divides, there will be 6 angles in that. So this formula will continue. Okay. So that you will do as an experiment at home. You will draw an angle, then divide it once, you will get this answer. Divide it 2, you will get this answer. Then you will divide it more and you will try that 1 plus 2 plus 3 plus 4 will be the answer. Understood? So that way you will experiment and make yourself confident that when angles are divided, further more new angles are formed and the number of angles formed can be calculated in this way, and the question will be very different way in your exam. That we will do it in the next video, but here I am putting the base for it. That time I won't explain, simply directly give you the answer. Let me go ahead. Let us think about triangle now. This is a triangle. We can divide the triangle into more number of triangles by dividing the triangle by drawing line from the vertex like this. I have made 1, 2, 3, 4 small triangle within a big triangle. So 5 triangle is, but we know that if I name this triangle as ABC, so ABC is a triangle. If I put D, E, F, so there is a triangle ABC, triangles ABC, then there is ABD, ABE, ABF, right? Is it over? No. ABD, ADE, in that way we can ADEO. This will go on. So after doing experiment on this particular figure and many such figure where a triangle is divided into a number of triangle by drawing from one of the vertex to the opposite side simple line segments, when you are drawing 4 line segments, as in this case 4 triangles are created, as in this case we know that 1, 2, 3, 4, 5 line segments or 5 lines are drawn from that vertex. In that case the answer happens to be 1 plus 2 plus 3 plus 4 plus 5, which is equal to 15 triangles are there if you name them. Otherwise simply count by drawing the line segment from the vertex to the opposite side. We divided the triangle into 4 triangles, then the answer is 1 plus 2 plus 3 plus 4 plus 1 more 5, and the answer is 15. Remember that. You will get interesting figures to apply your logic to get the answer in this topic. Moving ahead. Quadrilaterals, 4-sided figures. This is also something interesting. We know that this is a rectangle. If I divide this rectangle into, or the quadrilateral into a figure having 6 quadrilaterals, if I number it 1, 2, 3, okay, in that way. So there are 6. The question is, how many quadrilaterals are there here? If I name this as A, B, C, D, and then I start naming each point as E, F, G, H, you can imagine that how many is possible? ABCD is there, then each small square is there or rectangle is there, then 2 together makes another set, these 2 together make another set, these 2 make another set. So it becomes very tough for us to remember and find out how many quadrilaterals are there. Here also we have developed formula to find out how many quadrilaterals are there in this kind of figures. Understood? The formula is, let me write, if you write like this, first row 1, 2, 3. More is there, you will write 1, 2, 3, 4. And from here also, to down also, you start writing 1, 2, 3, 4. But only two rows are there and 3 columns. Understood? So the formula is 1 plus 2 plus 3, which we have written on the top, naming the number of columns, into number of rows like this. Whatever we get on multiplying, this is 6 into 3, 18 quadrilaterals are there. If you keep on naming it and writing the names of quadrilaterals, you will get 18 different quadrilaterals out of it. One way we feel relieved, अच्छा लगता है, easy रास्ता है. Another way we think that we should check it, that you do at home by drawing a rectangle like this and naming each point of intersection and naming it, and then name the quadrilaterals formed, and you will get 18 different quadrilaterals. Here is squares divided into 4 squares. The question is, how many squares are there? It is very clear to us that one big square and 4 small square, total is 5. So it's very easy. But a method has been developed to find out how many squares are there. It is in such a way that, just like in the case of quadrilateral, number this 1, 2. Here we will write 2. Then we will simply multiply these 2, which is 2 into 2. Then our answer is 5, we know. 2 into 2 plus the remaining digit, which is a digit remaining 1, which is equal to 5. So as it is very easy to find out the number of squares, 4 plus 1, 5 here, always it won't be easy. So then we should take a bigger square and try to find out whether this is right or not. Take a bigger square. Divide that square. Now, how many squares are there? We know that there is a big square, sure, and there are 3 into 3, 9 squares are there, 10 is guaranteed. But we know that if I name it like this, we know that this also make a square, this also make a square, this also make a square, this also makes square, like number is increasing. First the big square, then 9 square, तो 10 हो गया था. Another 4 we found, 14 मिल गया. But every time we cannot keep on counting like this. So we will do the technique 1, 2, 3, 2, 3. Multiply this just like before. That is 3 into 3, 9. Multiply this just like before, 2 into 2, 4, and the remaining digit is 1, total is 14. This way we can find out how many squares are there. Otherwise keeping it, counting it, naming it are difficult. This kind of shortcuts you have to apply whenever such questions come in the exam. This is about squares within squares. Continuing with squares. Suppose situation like this. Here these are also squares. But the original figure is not a square, it is a rectangle. But we know that there are 6 squares in front of us. Then squares are possible here. 7th one is there. This makes another, so 8 is there. I think 8 are there. So in this kind of situation, how we will apply the formula? We will write 1, 2, 3 like before, 2 here. Then we will extreme will be multiplied. 3 2s are 6. Remaining digits. Remaining larger digit we have to take. So that is 2. This is larger digit. Answer is 8. And it is applicable and it works. It works. If I say it, you will not believe. For that we should make another rectangle with more number of such squares. Right? Then only you will believe. So let me make squares in this. Okay, how many are there? 1, 2, 3, 4, 4 plus 4, 8 plus 1, 9 is guaranteed. But according to the new system, we will not keep on counting. We will apply the method. That means we will write 1, 2, 3, 4 here. And 2 here. and 2, we will multiply 2 into 4, which is equal to 8, and the larger digit is 3, so we will add that, total is 11. 11 squares are possible. You cannot simply believe like that. So do it and find out whether it is right or not. Draw a rectangle, make this kind of 8 squares in that, and name the square. First you name this rectangle as ABCD and name each point. Then you will see that there is a square here, there is a square here, there is a square here. Like that you will keep on counting. So you will find that 8 plus 3, 11 squares are there. Understood? One more we can try. There are 4 plus 4, 8 plus 4, 12. Then we'll do the same method. 1, 2, 3, 4, 2, 3. Multiply 3 into 4, which is equal to 12. The biggest, largest remaining is. So here is another possibility. You can multiply 2 into 3, which is equal to 6. Larger remaining is 2. That is, total is 20 squares are possible. Here a multiplication here, another multiplication here, add this largest digit remaining. So my dears, these are some techniques by which we can manage time logically. They are checking whether we have logic or not. We are applying the logic to solve the problem so that we are saving the time. Understood? Let me move ahead. Rectangle, pure rectangle. This is rectangle. The rectangle can be further divided into squares and rectangle. But this rectangle is having 4 square parts. Correct? 1, 2, 3, 4. Think that these are all squares. How many rectangles are there? This is a rectangle, A, B, C, D. These are squares. The question is, how many rectangles are there? So this is a rectangle from here to here. So 1 plus 1, 2. Here is a rectangle 3. Here is a rectangle 4. And the original given is rectangle 5. So the bigger one is 1. Then 2 together. 2, 3, 4, 5, 6 must be there. But every time we cannot keep on counting. So what we will do? An idea has been developed. The same way how we developed the idea by doing it on more rectangles. What is the number the square is given? And if there are 4 squares, 1 less than that you add. 1 plus 2 plus 3. Answer is 6. You have to check it with another rectangle, then only even I will believe. So we'll number it like this: 1, 2, 3, 4, 5. Correct? So we'll add 1 plus 2 plus 3 plus 4. Total 10 rectangles are possible. You have to check this. Naming this rectangle, naming each rectangle within that. Squares are not asked. Squares are not counted otherwise. 1 plus 2 will make a rectangle. 2 plus 3 will make a rectangle. 3 plus 4 will make a rectangle. Here I am saying 3 this square and 4 together will make a rectangle. 4 plus 5 will make a rectangle. 3, 4, 5 plus together will make a rectangle. 1 plus 2 plus 3 will make a rectangle. That way. But we don't have time to count like so. This technique is developed. If rectangles are asked, this is the method. Here is a rectangle, and within rectangle more rectangles. We can see 4 plus 1, 1, 2, 3, 4, small rectangle and a bigger rectangle which can be named as ABCD. But what is the total number of rectangles here? 4 plus 1, 5 we are sure, and these together, 1 plus 2 together make a rectangle, 2 plus 3 will make a rectangle, 3 plus 4 will make a rectangle. Then 1 plus 2 plus 3 will make a rectangle. The formula is 1 plus 2 plus 3 plus 4, which is equal to 10 rectangles are possible. If there are more bigger rectangles and more number of divisions, we will simply write 1, 2, 3, 4, 5 and simply add 1 plus 2 plus 3 plus 4 plus 5, which is equal to 15 rectangles are possible. So whenever you get time, you draw a rectangle and find out how these 15 are possible. It is possible. As I told you, 2 plus 3 make a rectangle, 3 plus 4 make a rectangle, 2 plus 3 plus 4 will make a rectangle, 1 plus 2 plus 3 will make a rectangle. Understood? So that way rectangles are possible. Here is a rectangle, and that rectangle has been divided into more rectangles within. That means rectangle is there, which is having rectangle within that. There are in front of our eyes 6 rectangles are there. But the total number of rectangles 6 plus 1, 7 and more, because we know that more rectangles are there. From here till here, this way also rectangle possible. Understood? And this way also rectangle possible. So there is a formula, a trick to find out a number of rectangles. Simply write like this and add 1 plus 2 plus 3 into 1 plus 2. This 1 plus 2. So how much it becomes? 1 plus 2 plus 3 into 1 plus 2, which is equal to 6 into 3, 18 rectangles are possible. Just by doing once and seeing once, you will not believe it. I should make another rectangle here now and write the number in that 1, 2, 3, 4 and 2 here. In this case, what I will do, 1 plus 2 plus 3 plus 4 into 1 plus 2. That means 10 into 3. 30 rectangles are possible in this. Number of rectangles are possible. So 30 are possible. So this way we have to apply the trick or tip or formula to get the answer in the exam, so that we can save time. That it goes. Here is another bigger one where there are 3 sets of, that means total rectangles are one bigger is there, and inside we are having 3 4 are 12 in front of us. But we will apply the formula 1, 2, 3, 4, 1, 2, 3. So what will be the formula? 1 plus 2 plus 3 plus 4 into, correct? 1 plus 2 plus 3. So here it is 10 and it is 6 and total 60 rectangles are possible. So throughout the video I am preparing you for answering some questions which are going to come in the exam, where the number of squares, number of rectangles in the given figure will be asked. Instead of sitting and counting and naming it, you will apply this tip or trick to find out. Sometimes it will be cube like this, regarding the faces of the cube, total faces, front face, back face, bottom, sideways faces are there. Such questions will come. So you need to have a figure of a cube in your mind. And this cube is having 8 cubes together make a big cube. Like 1, 2, 3, 4 on the top line, 5, 6, 7 and 8, which is not in our visibility. 8 cubes are there. So my dear students, there is no end for preparation for exam. It's an ongoing process. But facing the questions on a day-to-day basis will help you to become confident enough to face the question and get the correct answer. So the fundamental thing is practice. Do practice. Thank you.